All right, we're skipping the usual long intros today and just diving straight into the deep end. Welcome to the Special Explainer. We are about to trace the explosive 13.8 billion year biography of our universe. We're going to follow the unimaginable, chaotic journey of our home planet, literally through fire, ice, and massive cosmic collisions, just to figure out exactly how we ended up here.
Take a second to just think about the world around you today. The mountains, the oceans, the vast rainforests. Was our Earth always this lush and beautiful? Well, it's almost impossible to believe, but before all of this, actually before time and space even existed, everything in our vast universe was compressed into a single point that was smaller than a microscopic atom. There were no stars, no galaxies, and absolutely no Earth. Just unimaginable, tightly contained energy, just waiting for a spark.
And then, 13.8 billion years ago, that spark ignited the Big Bang. This infinite energy expanded outward in a fraction of a second. As this blindingly hot, chaotic universe finally began to cool down, a powerful new force stepped in: gravity. Gravity basically acted as the universe's ultimate sculptor. It started pulling those scattered energy particles together to forge the very first hydrogen and helium atoms.
So what happens next is pretty amazing. We get to see how this fundamental process builds into the birth of stars, including our own massive sun. As gravity condensed those giant clouds of hydrogen and helium, the pressure and the heat at their centers became so extreme that it triggered a relentless chain of nuclear fusion. The universe suddenly just lit up with billions of stars. And around one of these immense new stars, our sun, these swirling rings of superheated dust and gas began to orbit.
Okay, let's fast forward to 4.5 billion years ago, which is the true birth of our solar system. As those swirling dust clouds clumped together, they formed a solid crust. But I promise you, this was not an Earth you or I would recognize. We call this the Hadean Eon, and our planet was essentially just a chaotic, boiling mass of rock trapped under constant bombardment from asteroids.
The contrast between these two worlds is honestly hard to wrap your head around. Just imagine the terrifying Venus-like conditions of that early Hadean Earth. We're talking toxic skies completely devoid of oxygen, surface temperatures soaring past 200 degrees Celsius, and just endless rivers of glowing lava. Now compare that hostile apocalyptic destruction to the miraculous, life-sustaining planet we actually live on today. The transformation is staggering.
But Earth's chaotic infancy was about to get even more violent. Out of the darkness of space, a Mars-sized planet named Theia hurtled directly toward us. In what was basically a catastrophic near-miss collision, Theia smashed into Earth, shattering both planets' outer crusts. A massive ring of glowing debris was ejected into space, circling our planet kind of like Saturn's rings. Over time, gravity bound all this debris together to form our moon. And because it formed so close to us, if you were standing on Earth back then, the moon would have appeared 200 times larger in the ancient sky. No way you could miss that.
That colossal impact is actually the main reason why Earth and the moon are so fundamentally different today. Right after the collision, both were highly volcanic. But Earth possessed strong, heavy gravity. It acted like a protective shield, trapping the volcanic gases to form our life-giving atmosphere. The moon, on the other hand, with its much weaker gravity, simply couldn't hold on. Its gases just leaked right out into space, leaving it lifeless, exposed, and permanently scarred by craters. Jumping ahead to 4 billion years ago, we see this miraculous transition from a molten wasteland to a world literally overflowing with water. Earth was still enduring a relentless meteorite bombardment, but this violent assault actually brought a secret, life-saving ingredient.
The way this happened is completely wild. Those colliding meteorites weren't just rock. Many of them were effectively giant, dirty snowballs from deep space, completely packed with ice. So, when they struck the boiling surface of Earth, that ice instantly vaporized, forming colossal, thick clouds. These clouds gathered, and then the skies just opened up. Torrential rain poured down on the Earth continuously for millions of years. This epic, non-stop deluge finally cooled the boiling crust and filled up the great early oceans.
With oceans now covering the globe, we have to ask a truly fascinating question. Did life actually begin on Mars? It's a theory known as panspermia. Because Mars is smaller, it cooled down a lot faster than Earth did. Some scientists theorize that fully formed bacteria could have actually evolved in Martian oceans first. Then, when a meteor struck Mars, it blasted debris into space, carrying these microscopic Martian life forms, which eventually crashed into Earth, seeding our newly formed oceans with life.
Alternatively, life might have been a purely homegrown chemical miracle. The famous Miller-Urey experiment beautifully demonstrated this idea. Scientists recreated Earth's early atmosphere in a lab by mixing volcanic gases and simulating continuous, violent lightning storms. The result? They discovered the spontaneous formation of amino acids, which are the fundamental chemical building blocks of life. This proved that our violent weather could have quite literally sparked life into existence right here at home.
But the real miracle is what happened next down in the dark, protected depths of the ocean. Those amino acids began to combine, forming an outer shell to protect themselves. Inside, they generated the ultimate genetic blueprint, DNA. This incredible tiny molecule allowed single microscopic cells to multiply, to mutate, and eventually evolve into the complex life forms we know today.
Fast forward to 2.5 billion years ago, and this delicate early life was pushed to the absolute brink. The atmosphere began to change rapidly, plunging Earth into its first major extinction threat. We entered a terrifying era that scientists call Snowball Earth. Global temperatures plummeted to a staggering average of -18 degrees Celsius. The entire planet, literally from the poles to the equator, was encased in a thick shell of solid ice for millions of years. Yet, miraculously, deep beneath those frozen oceans, single-celled life held on. Eventually, massive volcanic eruptions shattered the ice from below, pumping carbon dioxide back into the atmosphere, trapping the sun's heat, and finally melting the global freeze.
As the oceans reopened to the sun, a biological miracle occurred, the oxygen revolution. Underwater plants began to thrive, absorbing that volcanic carbon dioxide through photosynthesis. In return, they pumped out massive amounts of oxygen. This drastically altered the atmosphere, making it possible for the very first amphibians to finally crawl out of the oceans and take a breath on solid land.
Now, let's picture the world 230 million years ago. The genetic code had rapidly mutated, giving rise to absolute titans. This was the dawn of the dinosaurs. They completely ruled the land, the sea, and the air. But life was definitely not easy. They lived in constant territorial struggles and even had to battle giant, highly venomous mosquitoes that could take down a massive beast with just a single bite.
But 65 million years ago, their reign met an apocalyptic end. A 27-kilometer-wide asteroid, traveling at an unthinkable 22,000 miles per hour, slammed right into the Gulf of Mexico. The immediate impact vaporized metal and rock, blasting it straight out into space. Within minutes, magnitude 12 earthquakes ripped the planet apart, spawning monstrous mega-tsunamis. As the ejected debris rained back down, it ignited the atmosphere, creating 800-kilometer-per-hour fiery dust storms and heating the air to a scorching 200 degrees Celsius.
That's 75%. That represents the sheer, unimaginable devastation of that single day. 75% of all species on Earth were wiped out. The giant dinosaurs were just completely erased from existence. The only survivors were those that required very little food. Specifically, tiny mammals weighing under 25 kilograms, just scurrying through the ashes of a destroyed world.
From those ashes, our mammal ancestors inherited the Earth. Over tens of millions of years, as global temperatures cooled down, massive, dense forests gave way to sweeping grasslands. Small mammals evolved into primates, adapting to these new environments. And then around 5 million years ago, a really critical geological event changed the course of history forever. A massive tectonic shift in Africa created a new mountain range, which completely blocked the vital monsoon rains. The lush rainforests where our ape ancestors lived safely in the trees quickly withered into dry deserts and dangerous grasslands. Facing starvation, our ancestors were forced out of the dying trees. To see predators over the tall grass and travel vast distances, they began to walk upright. The intense pressures of this harsh new environment sparked the rapid evolution of early humans.
And that brings us to today. We are the result of a miraculous, against all odds 13.8 billion year survival story. We made it through rivers of fire, global deep freezes, and literal apocalyptic asteroid impacts. Yet, despite outlasting all of nature's fury, a pretty somber truth has emerged. We are now the greatest threat to our own environment. Through massive pollution and human-driven climate change, we are destabilizing the very atmosphere that took billions of years to perfect.
Which leaves us with this really heavy, provocative thought. After surviving such an epic, incredibly fragile journey through the cosmos, will humanity be the sole cause of Earth's next great extinction?
It's a huge question of our ultimate responsibility. Thanks for joining me on this explainer. Until next time, keep questioning and keep exploring.